In this video, I'm going to go over the process of calibrating the oxygen electrode. The electrode has now been polarizing for some time, and we are ready to proceed with the calibration. You will have a OX1LP setup file delivered to you with the system on a C404 disk. This experimental file can be copied to your computer, and once your LabQuest Mini is connected to the USB port of your computer, of course, which you've done earlier because you've been polarizing electrode. When you open that experimental file, you will be shown this sensor confirmation window where you have to select the DO electrode as your sensor on channel 1 of LabQuest Mini 1, which is where we have it connected. There are 3 channels on your LabQuest Mini, and it's the oxygen electrode is connected to channel 1. So you say click connect, and now your electrode is recognized. We've got some old data here. I'm just gonna delete this data, clear all data, so we have no data in the file right now. And you will see the current dissolved oxygen reading shown in this meter. And if we click collect and start collecting the data, you will see the data being populated in this table, and you'll see the graph is starting to show a trace as well. But before collecting data, I'm going to stop this collection. I want to go through the calibration process, which is what one should do before using the electrode. So let me just delete the data by going to data, clear all data. And to calibrate the oxygen electrode, right now I've got air saturated water inside the electrode. You go to experiment, calibrate, select the DO electrode, and you'll see the sensor setting window. Ensure first that under calibration storage, you have experimental file selected, and under current calibration, you have experiment file selected. So this new calibration will be saved with this experimental file. You then select Calibrate tab here and go to Calibrate Now. It's a 2-point calibration, it's a linear calibration, and you will see reading 1 and reading 2. The reading 1 will be the first reading that we obtain, which is air saturated water, which is what's in the electrode right now. You'll see the voltage associated with that reading here, and you have to enter the value in milligrams per liter, which is the units that we are using in this file for the level of oxygen in air saturated water at the current temperature, which in this case is 21 degrees, and current atmospheric pressure. And you can get that number from a local weather station, which is about 101 kilopascals or 760 millimeters of mercury. And in your manual, you will find a table which will provide you with the values for expected dissolved oxygen levels in milligrams per liter at given temperature and pressure. In this case, it's 9 milligrams per liter in air saturated water at these conditions. We click keep on that first reading, and then we proceed to reading 2. For reading 2, we need to obtain a 0 dissolved oxygen measurement. And there are 2 ways you can do that. In your kit, you will find the sodium sulfide solution, which removes any oxygen from water, and we can use that. Or another way of doing it is by using the nitrogen gas, for example, and bubbling your solution with nitrogen gas. I'm going to use the sulfite. You do not need much, a couple of drops is all that's required, and you should be very careful with sulfite because you can poison your system if you add too much or don't rinse it really well. You will see here that the voltage is dropping rapidly once we've added sulfite. You wait for that voltage to stabilize, and it should be stabilizing around 0.85 volts or so. If it doesn't get all the way down, you may have to add another little drop of sulfite, but usually 2-3 drops for this 4 ml chamber is sufficient to obtain the 0. So you wait until this voltage stabilizes, and under reading 2 you will enter 0 milligrams per liter, but don't click keep until the reading is stable. So you keep monitoring this voltage reading here. You know, it's at 8.59 now, so it's almost there, still dropping a little bit. And when that is stable, we will be assigning 0 milligrams per liter to this voltage. And that's the calibration that's going to be set up in the software, you know, for this particular setup of the oxygen electrode. And it's really important that you recalibrate the electrode every single time you set it. And setting up the electrode at the beginning of day of experiments is a good idea. Leaving it overnight once set up is possible, you know, with some distilled water. But if the next morning you come in and you find your readings are not very stable, erratic in any way, then we recommend that you disassemble the electrode and assemble it and recalibrate. So now we're stabilized here at 8.4142. So I'm going to click keep. Now both readings have been obtained, and then you click done. And now you can see the reading here is 0 milligrams per liter, because you know, we've removed all of the dissolved oxygen from this solution with sodium sulfide. Before proceeding with the experiment, super important to get rid of this solution, okay, and rinse your electrode really well with fresh water to get rid of any traces of sodium sulfide. That is why I'm using here a syringe with a soft tubing tip, so I can add water to rinse it and then suck it back out to remove it and dump it without puncturing or damaging the membrane which is at the base of this electrode. Okay, so I've done that a few times, but one can certainly continue to rinse. And when you finish with rinsing, you add your new solution, suspension, or cells that you want to measure, and you bring down your plunger, again ensuring that water goes up the channel in the middle of the plunger about halfway up, and that there is no air bubbles in the electrode, in the chamber anywhere, because air bubbles are going to dissolve and they will cause problems with the readings. The readings will be noisy if you have bubbles there. Okay, and now we are ready to start data collection. Before you do that, you can click on this clock icon here where you can select the duration of your experiment and your sampling rate. The default is set up for about 60-minute experiment, 60 samples per minute. You can change that if you wish it longer or shorter. When you start the experiment, you just click collect, and your data will now populate in the graph table and on the meter. You can make changes to your graph. You can zoom in or zoom out by adjusting the minimum and maximum on the axis, like I'm doing right now. Okay, you can stop data collection before the experiment is finished, or continue on. One thing to remember is that in Logger Pro does not automatically save the data, so it's a good idea to continue to periodically save your experiment. Saving it under a new name is a good idea, or if you've already named the file, then save it to that file. And when you're finished collecting your data, you click stop, save again, of course, and you can later on export your data by going to File, Export As, and you export as CSV file which can then be saved onto your computer and then opened, in Excel for analysis. Or you can do analysis directly in this software. There's various statistical functions here you can obtain by clicking on the various functions. In the case of dissolved oxygen, if we're looking at trying to determine the rate of oxygen production or consumption, you can highlight the data that you're interested in, and then you would go to linear fit. Okay, and here you will obtain a window with information on the slope of that line, which would be your rate of change, and your, the correlation and some of the other y-intercept and that kind of stuff. So that's basically all with respect to data collection and calibration.